Mr. Klein here for clellandmaths. It's the ultimate advanced higher maths prelim revision video. Every single topic, just skip the ones you've not done it yet, and the PDF is in the link down below, so get the PDF so you can follow along. Also remember, we've got our members only live streams. We've got our ultimate prelim live stream tomorrow, and if you miss it, don't worry, because you can just catch up whenever you want, and there'll be a bonus PDF for that too.
clellandmaths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code clellandmaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code clellandmaths to get 30% off that. Link down below. QA Advanced Higher Maths 2025, Paper 2, Question 3. Express this in partial fractions. So we've got 2x squared minus 18x plus 4 all over x minus 1, x minus 3, x minus 5. So that's just a over x minus 1 plus b over x minus 3. And then it's just another linear factor, so c over x plus 5. So that means that I just say that the a gets times by all of that. A x point minus 3 and x plus 5 plus b times everything that is underneath the a and the c, x minus 1, x plus 5, plus c, everything that's under a and b, x minus 1, x minus 3, and that all equals the numerator, 2x squared minus 18x plus 4. So then we just pick numbers for x to eliminate. So I'm going to start off by picking x equals 3. So when x equals 3, a disappears, c disappears, leaving b, and it's going to be 3 minus 1, 3 plus 5 equals 2 3 squareds minus 18 3s plus 4. So working at your left-hand side there, that gives you 16b, 2 times 8. And working at your right-hand side, we've got 18 minus 54 plus 4. So 16b finally equals minus 32, and therefore b is minus 2. So we've got a b, now we pick a number again. Let's try x equals 1, eliminate b and c. So when x equals 1, so the first term we've got a 1 minus 3, which is minus 2, 1 plus 5, which is 6, and then the other ones can't disappear because you've got 1 in each of them, a minus 1. And then on the right hand side, you've got 2 times 1 squared, which is 2, minus 18 times 1, plus 4. So that's minus 12a equals minus 12, and therefore a equals 1. Finally, you need to just pick a random number, because if you pick minus 5, a and b disappear, but you've already, well, you could do that, I suppose. You could pick minus 5 and a and b would disappear to give you your c, or you could just pick a random number at this stage because you've already got a and b. So I think I'm just going to pick 0 because it'll just be easier. So when x equals 0, we've got for the first term a, which is 1, and then x minus 3, x plus 5, and then b, which is minus 2, and then it's x minus 1, x plus 5, so minus 1 and 5, because it's 0, and then c, and then we've got x minus 1 minus 3, so minus 1 minus 3, and that is going to equal the right hand side, but all the x's will cancel, so 0x squared, 0x, so just a number 4. Minus 3 times 5 is minus 15. Minus 2 times minus 1 is 2, times 5 is 10. Then we've got plus 3c equals 4. Minus 15 plus 10 is minus 5. So minus 5 plus 3c equals 4. So 3c equals 4 plus 5 is 9. So c is 3. So then we just shove it all back into a, b, and c. So finally, our answer is 1 over x minus 1 minus 2 over x minus 3 plus 3 over x plus 5. And we're done there.
2024 paper 1, question 1. Differentiate the formula with respect to x, y equals cot 3x, and y, f of x is 5x, 4x minus 7.5. So part A, we've got the chain rule to do here, so we've got the y by the x, and you check the start of the exam paper, and cot goes to cosec. So I've got cosec squared, 3x, and then I get times by that 3. So 3. So minus 3 cosec squared 3x. Just check that at the start of the exam paper. Cot goes to minus cosec squared. So yeah, that's fine. Right, part B, f of x is 5x, 4x minus 7.5. So a nice little product rule here, f dash x. So we've got uv. So it's vu dash, remember. So u dash is 5, and we'll just keep v as it is, plus u 5x times v dash, so that's a half, 4x minus 7 minus a half, and 8 times by the derivative, which is 4. So tidying that up as much as we can or want to, we've got 5, 4x minus 7 to the half. Half of 4 is 2, 2 5s is 10, so 10x, 4x minus 7 to the minus a half. And I think you'll probably get your marks there. You could probably go one step further and take 5, 4x minus 7 to the half out as a common factor. But you can end up with a messy thing in the middle. I'll show you what I mean. I could do 5, 4x minus 7 to the half, or even to the minus a half if you prefer. And that would give me just 1 plus 2x, and I would have 4x minus 7 still. And then I want to have a number which is minus 1. Half minus 1 is minus a half. So yeah, that's a little bit messy. So I think part B is fine. SQA Advanced Higher Maths 2024 Paper 2 Question 1. Given the y equals 7 sine 7x over 1 plus x squared, find the y by dx. So we're going to use the quotient rule. So we've got the y by dx is equal to v, 1 plus x squared, u dash, sine becomes cos. So it's 7 cos 7x, vu dash minus u sine 7x, v dash, well that's just times 2x, all over v squared, which is 1 plus x squared, all squared. Tidy that up a little bit, but it is only worth 2 marks. So I've got 7, 1 plus x squared cos 7x, minus 2x sine 7x, all over 1 plus x squared and squared. And let's see if we can do anything else with that. I'm happy to leave it like that, so I'm done there. SQA Advanced Higher Maths 2025, Paper 2, Question 2. A curve is defined by the equation 2y squared plus 4x e to the 2y equals 3x. Find an expression for the y by dx in terms of x and y. So this is implicit differentiation, and there's some product in here too. So let's look at the 2y squared. That becomes 4y. Every time you see a y, you get the y by dx when you differentiate it. 4x e to the 2y, so we've got a product there. So we've got v is e to the 2y times u, which is 4x, so that becomes 4 e to the 2y, and then plus 4x, and then we differentiate e to the 2y, so that's 2 e to the 2y, the y by dx, a dot for times, and 3x becomes 3.
And then we can move on from there. Oh look, there's a cat in the background. That's my cat, by the way. So we then collect our terms and simplify. So we've got 4y dy by dx. 4x times 2 is 8x. So 8x e to the 2y dy by dx equals 3. And then everything I don't want goes to the right. Anything that's got dy, not got dy by dx. So minus 4 e to the 2y. The y by the x is a common factor here. Now you can write the common factor part if you want, just to be very clear. You get 4y plus 8x e to the 2y equals 3 minus 4 e to the 2y. And then you can just divide by what you've got, which is the y by the x then is simply 3 minus 4 e to the 2y all over 4y plus 8x e to the 2y. And we're done there.
Grade Advanced Higher Maths 2023, Paper 2, Question 10. A curve is defined by y equals x to the 5x squared, where x is greater than 0. Find the y by dx in terms of x. So let's start off with y equals x to the 5x squared, which is an exponential. So we can take the log of both sides to start with. So log y equals log x to the 5x squared. We can separate out our right hand side, so log y equals 5x squared times log x, and then we can differentiate both sides. So differentiating the left hand side, log y becomes 1 over y, that is the y by dx, because we're differentiating implicitly, and the right hand side is a product. So we've got vu dash plus uv dash, so v is log x times u dash is 10x plus u, which is 5x squared, times v dash, which is 1 over x. And we'll just need to tidy it all up. So 1 over y, dy by dx is equal to 10x log x, just to make that neater, plus 5x squared over x is just 5x. Now we can times through by y. So that means that the y by dx is equal to y times 10x log x plus 5x. But we know what y is. Y is x to the 5x squared. So we're going to sub that back in for y. So the y by dx is x to the 5x squared 10x log x plus 5x. So the y by dx. Now we can take out more factors here. So we've got 5 is a common factor and x is a common factor. So we can take 5x out, I suppose. I'll write that out in long way. So I've got 5x times x to the 5x squared. So I've took 5x out. So that leaves me with 2 log x. And it also leaves me with plus 1 in the brackets. Remember, in maths, our most simple answers are factorised answers. So I'm going to try and leave it as factorised. So the y by dx. So I've got 5x times x to the 5x squared, so I can add the power, so that's just a power of 1. So that's going to be 5x squared plus 1. So I've got 5x to the 5x squared plus 1. I'll put that in brackets for clarity. And that's times by 2 log x plus 1. And that's as simple as it's going to get. So I'm done there.
Advanced Higher Maths 2025, Paper 2, Question 7. A curve is defined on a suitable domain by x equals t squared and y equals tan t. Find the y by the x and d2y by the x squared. So the y by the x is the y by the t times the t by the x. So I'm going to need to work out both of these things. So the y by the t at the side, well that's easy enough. Tan t, start of the exam paper is sec squared t. The x by dt is just 2t. So that means we've got the y by dt, which is sec squared t. The t by the x is the x by dt flipped upside down, essentially. So that's just over 2t, which is just times by 1 over 2t. And we're done there for part A. Part B, d2y by dx squared. Well, we want d by dt of the y by dx, so we don't have a choice anyway. And then we want to times by something. Well, how do you remember that? I want the dt's to cancel, so I'm going to have the t on top. And I want a dx squared on the bottom, so I need a dx. So differentiating this, the y by dx, it's the quotient rule. So I've got 2t v times u dash, well, sec squared t, 2 times sec t to the power of 1 times the derivative of sec t, which is sec t tan t from the start of the exam paper. Keeps you on your toes, that one. All times by 2t, so that's vu dash minus u times v dash, which is 2, so I'll just put the 2 outside. So that's all over v squared, 2t squared, which is 4t squared, all times by dx by dt, which is dt by dx, which is 1 over 2t. Simplify as much as we can. 2 2s is 4t sec squared t tan t minus 2 sec squared t all over 8t cubed. Take out common factors on the top. So we've got 2 as a common factor. Sec squared t is a common factor. Leaving with 2t tan t minus 1 over 8t cubed. A 2 cancels on the top, leaving sec squared t, 2t tan t minus 1, all over 2 cancels on the bottom, 4t cubed. Basically, Advanced Higher Maths 2025, Paper 2, Question 17. The volume of a water in a tank is given by V equals a fifth h cubed. Water is being piped into the tank at a rate of 6 centimeters cubed per second. What does that mean? Volume per second, rate, the V by the T in some way equals 6. That says in. Leaking out at a rate of 1 over 10 root h. So our dv by dt out is equal to 1 over 10 root h. So that means that our net, I suppose, dv by dt, the difference between the out and the in, must be 6 minus, that's a h, root h over 10. I don't know why I'm writing tens here. 6 minus root h over 10. It says calculate the rate of change of the depth of water when h is 100. So we know this, dv by dt. And we know that v is 1/5 h cubed, so we know dv by dh is 3/5 h squared. So we want to know the rate of change of the depth of water, the height, in other words, dh by dt, because rate of change is out of time. So we've got that. So if we have that, we need a h. So we've got dh by dv there, because we've got dv by dh. And we want to get rid of the dv, so we've got dv by dt. So there we are. Very careful at this point. We've got dh by dv, which is this upside down. So 3/5 h squared becomes 5 over 3h squared times the v by dt, which is 6 minus root h over 10. Now, h is equal to 400 implies that the h by dt then is 5 over 3 times 400 squared times 6 minus the square root of 400 over 10. So that's just 5 over 3 times 4 4s is 16, 0, 0, 0, 0. And then we've got 6 minus 20 over 10, which is 2, so that's 4. 20 over 3 times 160000 is 480,000, which simplifies to divide by 4, 480, 123 divided by 20 is 24,000. 1 over 24,000 centimetres per second, which is how I'd probably leave it. But just to show you how small that is, 0.000042. But I'd leave it like that. And we're done there.
Basically, Advanced Higher Maths 2024, paper 1, question 8. Use the substitution use tan 2x to evaluate this integral. Okay, let's start with u equals tan 2x then. So we're going to have to get rid of the dx anyway. So even if you don't know what to do, you should just start with that. du by dx. Well, sec squared 2x. Start the exam paper if you don't know, times it by 2 because of the chain. So that means that dx times that is du. So dx is du over that. 2 sec squared 2x. Now you might not be able to see what's going on, so just sub it in and see what happens. So let's have a look. Root tan 2x, well, u is tan 2x, so that's the root u I've got. And then we've got cos squared 2x on the bottom. I don't know what the hell that is, so let's just leave it where it is. And I'm timesing that by du over 2 sec squared 2x. Well, that's root u over cos squared 2x times du over 2 times, well, sec is 1 over cos, third letter, helps to remember that. So 1 over cos squared 2x. Well, that's handy because we just cancel each other out. So that gives me root u du over 2. So now we can do our limits. So we've got 0 and pi over 8. So when x equals 0, u equals tan of 0. And the tan of 0 is 0. And when x equals pi over 8, u equals tan, it was 2x, I think. So 2 pi over 8, which is pi over 4. Pi over 4 is 45 degrees. The tan of 45 is 1. So that means our integral just becomes the integral between 0 and 1 of root u du over 2. So that's a half of the integral between 0 and 1 of u to the half du. So what does that give me? That gives me a half, add 1 to the power, divide by the new power, 3 halves becomes 2 thirds. And that's between 0 and 1. So subbing in our numbers, that's a half, 2 thirds times 1 to the 3 halves, minus 2 thirds times 0 to the 3 halves. That's just a half times 2 thirds then, because 1 to the power of anything's 1, and then I've got 0. That's just 2 over 6, which is 1 over 3. And we're done there.
The Advanced Higher Maths 2025, paper 2, question 16. Use integration by parts. Integration by parts formula reminder is the integral of uv dash equals uv minus the integral of vu dash. So you let one of them be one to differentiate and one to be integrated. Now there's tricks you can do with this, but I'm not going to do it without tricks. So for the first step, I'm just going to let this be I. You'll see that one never disappears. So at some point, what's going to happen is you're going to get a multiple of it on one side, and you're just going to have to then sub it in. So let's see what we've got. Let u equals sine 5x, say. And that means that u dash is equal to 5 cos 5x. Then that means that I'm saying v dash was equal to e to the 2x. So v integrating that is a half e to the 2x. So our integral is uv. So that's a half e to the 2x sine 5x minus the integral of v, which is a half I can take outside, e to the 2x, and then u dash, which is 5, so I'll take the 5 out as well, cos 5x dx. So let's look at the integral of e to the 2x cos 5x dx. So we'll just start again with that. Let's say that we'll let v dash equal e to the 2x. So v is equal to a half e to the 2x. U is cos 5x. This means that u dash is equal to cos integrates to sine. No. So u dash is equal to cos differentiates to minus sine times 5. So the integral of e to the 2x cos 5x is uv, which is a half e to the 2x cos 5x minus the integral of v u dash. So I've got a half. U dash is a 5, and a minus makes a plus. So v u dash inside is e to the 2x sine 5x dx. But e to the 2x sine 5x is what I called I. So that equals just a half e to the 2x cos 5x plus 5/2 of I. Therefore, we can say that I equals, way back up here before we even got anywhere, 1/2 e to the 2x sine 5x minus 5/2. That says minus 5/2. The integral of e to the 2x cos 5x we've just worked out is this thing here. So that's a half e to the 2x cos 5x plus 5/2 of I. So tidying that up a little bit, I is a half e to the 2x sine 5x. 5/2 times a half is 5/4. E to the 2x cos 5x. And then 5/2 times 5/2 is 25/4 of I. Move the i's all over the same side then. We've got I plus, that should be a minus 25 over 4, sorry. So that becomes 25 over 4 plus 4 over 4 is 29 over 4i equals a half e to the 2x sine 5x minus 5/4 e to the 2x cos 5x. So finally, we get our integral I is equal to, well, times all this by 4. So 4 times a half is 2, e to the 2x sine 5x. 4 times 5/4 is just 5, e to the 2x cos 5x, all over 29. And we've got a plus c, of course, don't forget that right at the end because you've never added it in. And we're done there. Advanced Higher Maths 2024, Paper 2, Question 15. A storage tank contains a mixture of salt and water. An additional amount of salt and water pours in while at the same time some of the existing mixture pours out. The process can be modelled by this first order separable differential equation where W can't be less than 36. W is the amount of salt in kilograms at time t minutes. Initially, the storage tank contains 8 kilos of salt. Express W in terms of t. Okay, part A. So I've got dW, 120 of that, equals 36 minus W times dt. So in other words, dW over 36 minus W equals dt over 120. Integrate both sides in. That's a log for this one, so it's the log of 36 minus W, but chain rule, remember, applies, so times minus 1. That equals, well, that's just 1 over 120, and we've got t, so it's t over 120 plus some constant, let's call that c. And therefore W equals minus e to the minus t over 120 plus d plus 36. So now we can separate our variables out, minus e to the minus t over 120 times e to the d plus 36. We'll just save it, let a equal e to the d. So w equals minus a e to the minus t over 120 plus 36. I mean, initial conditions were that when t equals 0, w equals 8. So that means that 8 equals minus a plus 36. So a must equal 36 minus 8, 26, 27, 28. And therefore w equals minus 28 e to the minus t over 120 plus 36. And we're done there. Part B, find the rate at which the amount of salt is increasing after 67 minutes. So we want to know what the w by dt is at t equals 67. Two ways to do this. You could go back to your initial equation, and since you've already got w here, you could sub 67 in to get w, and then sub w into get into dw by dt. That's one way, or a better way. Let's just work out dw in terms of t, dw by dt, using this formula. So we've got e to the minus t over 120. So that's still e to the minus t over 120. We've got minus 28, but that's going to be times by the derivative of t over 120 minus, which is just 1 over 120. So you'll get 28 over 120. And then you've still got plus 36, but that's gone. So at t equal to 67, dw by dt is 28 over 120 e to the minus 67 over 120. Doing that in a calculator then, e to the power of minus 67 over 120 is that, times 28 over 120 is 0.134. And the rate would be kilograms per minute. So we're done there. Part C. As the process continues, the amount of salt approaches a limit, L kilograms. Find the value of L. So W equals minus 28 e to the minus t over 120 plus 36. So we're wanting to know what happens as t goes to infinity. Well, w goes to minus 28 e to the minus infinity over 120, which is still minus infinity, plus 36. So we need to know what happens to e as it approaches negative infinity. Well, there's the graph of e. As that gets smaller and smaller, it gets closer and closer to 0. So we can say that w approaches 0 plus 36. So w approaches 36, which means our limit L is equal to 36 kilograms. And we're done there.
Question 8, differentiate egg log x minus x with respect to x, and then part B, find the general solution to this differential equation. So part A, let's say y equals x log x minus x, and we're going to use the product rule on x log x. So we've got u is equal to x, we've got u dash is 1, and then v is log x, of course, which means v dash is 1 over x. And just a reminder, so we've got u dash v plus v dash u. So that's 1 times log x plus 1 over x times x, or log x plus 1. So that means that on this side, differentiating it, the y by dx must be log x plus 1 minus 1, because differentiating of x is just 1. So the y by dx in this case is just log x. Part B, hence find the general solution to this differential equation. The y by dx plus y log x equals x to the power of minus x. So our integrating factor from part 1 is simply going to be e to the power of the integral of log x dx. And we know then that is just going to be e to the x log x minus x. So that means our integrating factor is e to the log of x to the power of x times e to the minus x. So that means our integrating factor is just simply x to the power of x times e to the minus x. So we can just times both sides by our integrating factor. So we've got x to the power of x e to the minus x dy by dx plus y x to the power of x e to the minus x log x, and that equals the right hand side, which is x to the power of minus x times x to the power of x e to the minus x. So that implies we've got d by dx of x to the power of x e to the minus x times y equals e to the power of minus x. So x to the power of minus x e to the minus x y must equal the integral of e to the power of minus x dx. So x to the power of x e to the minus x y equals minus e to the minus x plus c. And therefore y is just minus e to the minus x plus c over x to the power of x e to the minus x. And that final answer can be left in a lot of different ways.
SQA Advanced Higher Maths 2023, Paper 1, Question 5. Find the particular solution of this differential equation. So let's set up our m squared minus m squared minus 4m minus 5 equals 0. And that gives us m and m. It gives us 5 and 1. Minus 5 plus 1 equals 0. So x equals minus 1 or x equals 5. So for our general solution, we know it's going to be in the form of, well, this is two distinct roots. So you're going to have y equals a e to the minus x plus b e to the 5x. So now let's work on our right hand side. We have got 10x squared plus 11x minus 23. Looking at our right hand side, since we've got 10x squared plus 11x minus 23, the form is going to be y equals ax squared plus bx plus c. So now we can differentiate that twice to find dy by dx and d2y by dx squared. The y by dx is just going to be 2ax plus b, and d2y by dx squared is simply going to be 2a. So now we can sub that back into the original equation. So the original equation was d2y by dx squared minus 4 dy by dx minus 5y equals 10x squared plus 11x minus 23. So d2y by dx squared is 2a minus 4 times 2ax plus b, and then we've got minus 5 times ax squared plus bx plus c, and that equals our right hand side, but let's just tidy that up. That gives us 2a minus 4 2s are 8ax minus 4b minus 5ax squared minus 5bx minus 5c. Putting it all in the right order, you'll have minus 5ax squared. That's that one done. Then minus 8ax minus 5bx. That's that one done and that one done. Plus 2a minus 4b minus 5c, and we're going to equate that to 10x squared plus 11x minus 23. So equating the left and the right hand side, that implies that minus 5a is equal to 10, so a is equal to minus 2. Looking at our x terms, we have got minus 8a minus 5b equals 11. Minus 8 times minus 2 is 16, minus 5b is 11, so minus 5b is minus 5, so b is equal to 1. Now looking at our constant terms, we have got 2a minus 4b minus 5c is equal to minus 23. 2a is minus 4, 4b is also minus 4, minus 5c is minus 23. So you get minus 8 minus 5c is minus 23. Minus 23 plus 8 is minus 15, so minus 5c equals minus 15, and therefore c is equal to 3. So now we know that our y must equal a e to the minus x plus b e to the 5x minus 2x squared plus x plus 3. So now we can differentiate that, because we also know from the start of the question, way back up here, that when y is 2, the y by the x is 14 when x is 0. So finding our dy by dx first, that's minus a e to the minus x plus 5b e to the 5x minus 4x plus 1. So when y equals 2, we get 2 equals a plus b, and then 0, 0 plus 3. Or to put it a better way, a plus b equals minus 1. And then when dy by dx equals 14, we get 14 equals minus a plus 5b plus 1, or minus a plus 5b equals 13. So we've got two equations to solve simultaneously. I'll just write them one above the other. 5b plus b is 6b. 13 minus 1 is 12, so b is equal to 2. And then subbing that into a plus b equals minus 1. You've got a plus 2 equals minus 1, so a equals minus 3. So then we can just now write our final solution, y equals minus 3 e to the minus x plus 2 e to the 5x minus 2x squared plus x plus 3. And finally, we're done there. Advanced Higher Maths 2025, Paper 2, Question 9. Relative to a fixed origin, the velocity in meters per second of an object at time t is given by v equals 2t plus 5 e to the 5t. Find the expression for displacement, which is the integral of v to t, in terms of the object, given that t and z equals 0 when s is 0. So I need to integrate velocity, which is 2t plus e to the 5t dt. 2t is obviously add 1 to the power t squared, divided by the power. E to the 5t is still e to the 5t, but then times a fifth. But then you've got plus c. So your initial conditions now, t equals 0, s equals 0. So that implies, because this is s, that 0 equals 0 plus a fifth e to the 0 plus c. So 0 equals, well, e to the 0 is 1, so a fifth plus c. So that means that c is negative 1/5. So our s is simply t squared plus a fifth e to the 5t minus a fifth. And we're done there. Part B, show the acceleration is always positive. So v is 2t plus 5 e to the 5t. and a is dv by dt, which is 2 plus 5 e to the 5t. So we kind of need to show that, is this always positive somehow? Well, let's look at e to the 5t. That's always greater than 0 for all t a member of the real numbers. Because if t is positive, you've got, well, e to the positive number. And if it's negative, you've just got a fraction. So no big deal there. And that means that, therefore, 5 e to the 5t is always greater than 0 for all t a member of the real numbers. And that means that your acceleration, which is 2 plus e to the 5t times 5, of course, is always greater than at least, well, 2. Because e to the 5t can kind of go towards 0, it never really gets there. So since it's always greater than 2, that means that a is always greater than 2, so a is always positive. And we're done there. Advanced Higher Maths 2024, paper 2, question 8. A solid is formed by rotating part of a curve with equation y equals 1 over the square root of 1 plus x squared about the x-axis through 2 pi radians from 0 to x equals a. And the value of the volume is pi squared over 3. Find a. So the volume is v equals the integral of pi times y squared dx. And we have got between 0 and a. And that equals, just to remind us, pi squared over 3. So as long as you know that, this question should be reasonably straightforward. So that's pi times, well, if the integral of 0 to a, y squared, let's have a look, 1 over square root of 1 plus x squared, 1 plus x squared dx equals pi squared over 3. So check that example for that one. I think that's the inverse tan. So that becomes pi times the inverse tan of x between 0 and a equals pi squared over 3. So that's pi times the inverse tan of a minus the inverse tan of 0 equals pi squared over 3. So you can eliminate a pi for both sides then, and the inverse tan of a we get on this side minus the inverse tan of 0 is 0. That's not times by pi anymore because I'm just going to say that's pi over 3, just to eliminate a pi for both sides. So that means the inverse tan of a is pi over 3. So that means that I can just kind of work that out. If I draw an exact value triangle, I'm just going to think in degrees and then change it back. 2, 1, root 3. If the inverse tan of a is pi over 3, that means a must have been 60 root 3. And we're done there. A system of equations defined as this. Use Gaussian elimination to see if they're redundant, inconsistent, or have a unique solution. So let's set up our Gaussian elimination. We've got 1 minus 3, 1 minus 1, 3 minus 2, 4 and 11, 1, 4, 2 and 15. And remember, the goal here is simply to get zeros in these three places. So the first thing I can do is do row 3 becomes row 3 minus row 1. But simultaneously, I can do row 2 becomes row 2 minus 3 row 1. So being very careful, we get 1 minus 3, 1 minus 1. 3 minus 3 is 0. Minus 2, but then it will be plus 9 is 7. 4 minus 3 is 1. And 11, and it will be plus 3 is 14. And then the bottom one, row 3 minus row 1 gives you 0. 4 plus 3 is 7. 2 minus 1 is 1. 15 plus 1 is 16. Now we can get a 0 in this place by doing this minus this. So row 3 becomes row 3 minus row 2. So we can have 1 minus 3, 1 minus 1, 0, 7, 1 and 14, 0, 7 minus 7, 0, 1 minus 1 is 0, 16 minus 14 is 2. 0x plus 0y plus 0z equals 2. 0z cannot equal 2. So therefore, the system is inconsistent.
SQA Advanced Higher Maths 2023, Paper 2, Question 3. The matrix A is defined as this matrix, where x is a member of real numbers. Find an expression simplified for the determinant of A for 2 marks, and then determine whether the inverse exists for all values of A. So the determinant of the matrix, let's start with that. So we're going to have 2, and then we delete these rows and columns times the determinant of this matrix. So 2 times minus 1, 0, 0, minus 2. And then it's minus 2x times the determinant of, I'll delete this row and column, x0, 1, minus 2. And then it's plus again the 4 times the determinant of x minus 1, 1, 0. So then we can go ahead and solve that. So that gives us 2 times 2 minus 2x times minus 2x. Plus 4 times, and be careful now, it's just 1 because it's 0 minus minus 1. So that gives us 4 plus 4x squared plus 4, or a nicer way, 4x squared plus 8. And we're done there. Let's move on to part B. Part B, with the determinant for which values of x the inverse matrix exists. So our determinant, remember, is equal to 4x squared plus 8. And for the inverse to exist, the determinant cannot equal 0. So for the inverse to exist, det A cannot equal 0. So we're just looking to see what values of 4x squared plus a can x be so that it's never 0. So we've got 4x squared plus 8. That is never equal to 0. And why is that? Because x squared is always greater than or equal to 0. And that means you could then say that 4x squared is all plus 8 would always greater than or equal to, well, it would be 8. Because you would have, if you square a number, the smallest you can get is 0 plus 8 is 8. And therefore, the inverse exists for all values of x.
Advanced Higher Maths 2025, Paper 1, Question 4. Matrices A and B are defined as base. Find 3a plus 2b. So a little bit of matrix work. So we've got 3a plus 2b. So timesing everything in A by 3 gives me minus 9, 6, 0, and 3, plus 2 2's is 4, and 10, and 2 lambda. Adding them together, just add each individual term. Minus 9 add 4 is minus 5, 6 add 4 is 10, 0 add 10 is 10, and you get 2 lambda plus 3. And that's as done part A. Part B says, find A transpose B. So A transpose, A was minus 3, 2, 0, 1. So we just flip the columns, minus 3, 2, 0, 1 times B. Well, B was 2, 2, 5 lambda. So remember, this works by just timesing the row and the column, and that gives us our first term. Then row and column for second term, row and column for third term, row and column for fourth term. So that gives me minus 3 times 2 is minus 6 plus 0. Minus 3 times 2 is minus 6 plus 0 again. 2 2's is 4. 4 plus 5 is 9. And then 2 2's is 4 plus lambda. So we get that. Find an expression for the determinant of A dash A transpose B. So the determinant of a 2 by 2 matrix is just this times this minus that times that. So we've got minus 6, 4 plus lambda, minus 6 times 9. So that gives me minus 24 minus 6 lambda. A minus times a minus is a plus, so plus 54. That gives me 30 minus 6 lambda. And then part C, determine the value of lambda such that A prime B is singular. So singular means that there's no inverse, so that implies that the determinant of A prime B is equal to 0 because you've got no inverse. Inverse doesn't exist. So inverse doesn't exist when the determinant is 0, 6 lambda equals 0, 6 lambda equals 30, lambda equals 5, and we're done there. A-Squared Advanced Higher Maths 2025, Paper 2, Question 8. A matrix has the following properties. A squared is 6a minus I, where I is the identity. Express A cubed is PA plus QI. Okay. A cubed is just A times A squared. So that is equal to A times 6a minus I. So that equals 6a squared minus AI, but a matrix times the identity is just the same as times by 1 essentially, it's just A. So that equals 6a squared minus A. And now we've got A squared again, so we can just say we've got 6a minus I minus A. 36a minus 6i minus A is 35a minus 6i. PA plus QI. We're done there. Matrix A is not singular. Find an expression for A inverse in terms of A and I. So not singular means that A inverse exists. Now what's the determinant? It's not equal to 0. So A squared is 6a minus I. And I want to try and get the inverse. So what you can do is introduce the inverse of A to both sides. So I've got A inverse A squared equals A inverse 6a minus I, making sure that you're keeping the order that you introduce it important, the left or the right. So that gives me A inverse A times another A. And that gives me 6, doesn't matter about 6, A inverse A minus A inverse I. But anytime you see A inverse A, that's just I. So that's just IA equals 6I. And then I times a matrix is just the matrix itself, so A inverse. So we get that far, and we can just make A inverse the subject. So I'll move it to the left. So we get A inverse equals 6i staying where it is, minus IA. Now, IA I've forgot to get rid of, so let me just get rid of that. 6i minus A, or minus A add 6i, whatever way you like. Does it tell us a form? Nah, in terms of A and I, 6i minus A, and we're done there. A-Squared Advanced Higher Maths 2023, Paper 1, Question 9. State the matrix A associated with an anticlockwise rotation of pi 2 radians about the origin. So for part A, we just go to the start of our exam paper and sine a theta, with a rotation of theta anticlockwise about the origin is cos theta minus sine theta cos theta. So then we can just say our answer is cos pi over 2 minus sine pi over 2 sine pi over 2 cos pi over 2. So the cos of pi over 2, the cos of 90 is 0. So we get 0. The sine of 90 is 1. So we get minus 1, 1 and 0. And we're done there. The matrix B is given by this matrix. AB is associated with an anticlockwise rotation of alpha radians. Determine AB. So for part B, A times B is equal to 0 minus 1, 1, 0 times our matrix minus root 3 over 2, a half, minus a half, and minus root 3 over 2. Multiplying them together, we've got 0 times that minus 1 times that is a half. 0 times a half is 0, minus 1 times this is root 3 over 2. 1 times minus root 3 over 2 plus 0 is minus root 3 over 2. And 1 times a half is 1, and 0 is a half. So there's AB. It then says, find the value of alpha. Now, remember, this represents an anti-clockwise rotation. So we're looking at cos theta minus sin theta, cos theta again. So for part 2, I know that cos theta must equal a half. The inverse cos of a half is equal to 60 degrees or pi over 3, but is also equal to another answer of 300 degrees, which is 5 pi over 3. So it's one of those two, so when we need to examine another one, so let's examine this one here, sin theta. Sin theta is minus root 3 over 2. The inverse sine of root 3 over 2 is simply pi over 3. So using our cast diagram, sine is negative in this case, so we get pi plus pi over 3 and pi minus pi over 3. So this one again leads to 5 pi over 3. So 5 pi over 3 for that one. Go alpha is equal to 5 pi over 3, and we're done there. Part C, determine the least possible interval of n such that a, b to the n equals I, where I is a 2 by 2 identity matrix. A couple of ways you can do this actually. You could just keep doing it over and over again, but there is a simpler way. If we think of AB as our rotation is 5 pi over 3, we're saying that for part C, AB to the n equals the identity matrix, which means if you think about it going around 5 pi over 3, how many times does it have to go around 5 pi over 3 till it gets back to where it started? So in other words, we're saying that n, in some multiple of 5 pi over 3, has to go around be 2 pi to get back to where it started. So some multiple of 2 pi. And we're just solving for that. So we're looking for the first value of n, which produces a multiple of 2 pi. So if we try 1, we get 5/3 pi. That's not a multiple of 2 pi. Try 2, it's obviously not going to work. 3 is going to give us 5 pi, which isn't 2 pi. 4 or 5 is not going to work. If we try 6, 6 over 3 is 2. 2 5s is 10. 10 pi is a multiple of 2 pi. So n equals 6, and we're done there. This has been clellandmaths today. We've looked at the Advanced Higher Maths 2023 Paper 1. Take care, stay safe, and goodbye. Advanced Higher Maths 2024 Paper 2, Question 14. A plane passes through A, B and C. Determine A, B and AC. Part of reason you through this one. A, B is like higher maths, B minus A. So that is, I'm not even sure we're working for this, guys. 1 minus 2 is minus 1. 1 minus minus 1 is 2. Minus 1 minus 8 is minus 9. Okay, AC. C minus A. 4 minus 2 is 2. Minus 2 minus minus 1 is minus 1. 11 minus 8 is 3. So we get our two vectors there. Part 2. Hence, find the Cartesian equation of the plane. So we've got a plane. What's a plane? Where's a plane? We've got 3 points, A, some B and C. I don't know where they are, but this will do as a picture. So we've got two vectors like that. So we've got a normal to those points at A. So to work out that, it's the cross product. So we do AB cross AC. Now you can use that exam paper for this. It is a matrix, IGK. AB is minus 1, 2, minus 9. And AC is 2, minus 1 and 3. So using this exam paper to help me, is the determinant of 2 minus 9 minus 1 3 times I minus the determinant of minus 1 minus 9 2 3 times j plus the determinant of minus 1 2 2 minus 1 times k. Our 2D determinants. 2 3s is 6 minus 1 times minus 9 is 9, so 6 minus 9 is minus 3. I. Minus 3 minus minus is plus 18. 18 minus 3 is 15, so it's minus 15j. And then we've got minus times minus a plus, so that's 1 minus 4. 1 minus 4 is minus 3. Okay, but any normal will do. So if I write that as minus 3 minus 15 minus 3, why don't I just take out minus a third as a common factor to get 1, 5, 1, because that's much nicer to work with. Just remembering that we then just do n dot r equals n dot a, b or c, doesn't matter what point you use. I think I'm going to use b because the numbers are easier, 1, 1 minus 1. So I'm just going to use that as my normal because why not, any normal will do. So I've got 1, 5, 1, x, y, z equals 1, 5, 1, and then the point I'm going to use is 1, 1 minus 1. So that gives me x plus 5y plus z equals, let's just work this bit out, 1 times 1 is 1, 5 times 5 is 5, 1 times minus 1 is minus 1, that just equals 5. And there's the equation of our plane. Part B, the line defined by these equations show that the line and plane don't intersect. Let me just copy these equations down to the rest of that page. Okay, I'm going to do this using parametric equation, because that's the way I always do something like this. I'm going to let that equal, say, t, and then I get x minus 1 equals t, which implies x equals t plus 1. I get y plus 1 equals minus t, which implies y equals minus t minus 1. And I get z plus 1 equals 4t, which implies that z equals 4t minus 1. So I've got my equations of the line and the point, so I'll just sub them in, and hopefully I'll get a contradiction if it doesn't work. That'll be inconsistent. So I've got subbing in, I get x, which is t plus 1, plus 5y, which is minus t minus 1, plus z, which is 4t minus 1, and that's meant to equal 5, but I'm not going to write equals 5. I'm just going to sub in to see the point of intersection. Well, that's meant to equal 5, yeah? So we get t plus 1, and we get minus 5t minus 5 plus 4t minus 1 equals 5. Plus 1 is 5t, minus 5t is 0. Then we've got 1 minus 1 is 0, so you get minus 5 equals 5. Well, minus 5 cannot equal 5, so therefore no point of intersection. And we're done there. Advanced Higher Maths 2023, Paper 1, Question 6. Express z equals 1 plus root 3i in polar form. Quite standard stuff this. We need the modulus of z, which is a bit like Pythagoras, I suppose. You've got 1 squared plus root 3 squared, square rooted. That's 1 plus 3. I'll just go straight to 2, shall we? And we're done there. And then we need the argument of z. So that's going to be the inverse tan of root 3i, so root 3 over 1. Non-calculator paper, you should just know the inverse tan of root 3 is 60 degrees. Which is pi over 3. Means that z equals 2 times the cos of pi over 3 plus I sine pi over 3. And we're done there. Part B, hence it otherwise show that z cubed is real. So z cubed, we can use the Moivre's theorem for this. That's going to be 2 cubed times the cos of 3 pi over 3 plus I sine 3 pi over 3. Well, 2 cubed is 8. Cos of 3 pi over 3 is just the cos of pi plus the I sine the pi. And you should know what the cos of pi and the I sine the pi is. The cos of pi minus 1. And the sine of pi is 0. So that gives us 8 times minus 1, which is minus 8, which is a member of the real numbers. Therefore, z cubed is a member of the real numbers. And we're done there.
Question 3, given that z1 is 5 plus 3i, z2 is 6 plus 2i, express z1 times the complex conjugate of z2 in the form a plus ib, where a and b are real numbers. So, we've got the complex conjugate of z2 is just 6 minus 2i. So z1 times z2 bar is just going to be 5 plus 3i. 6 minus 2i. Expanding the bracket, so we get 30 minus 10i plus 18i minus 6i squared. But remember, I squared equals minus 1. So z1, z2 bar
Advanced Higher Maths 2024, Paper 2, Question 12. Given that z equals x plus iy, where y is not equal to 0, solve that equation. Where z bar is the complex conjugate of z. That's nice of them telling us. We should know this anyway. So we'll just sub it in and just solve. No big deal, surely. X plus iy squared plus 20 x minus iy, because it's a complex conjugate, minus 156 equals 0. So let's just see where we get with this. X squared plus 2xyi plus I squared y squared plus 20x minus 20yi minus 156 equals 0. Let's collect all the real terms in the same bit together. So I've got x squared plus 2xyi minus y squared, because I squared is minus 1, plus 20x minus 20yi minus 156. And think of that 0 is 0 real plus, well, 0 imaginary either. So 0 plus 0i, you can think of that as. So you can just say that the real part, so looking at the real part of this side, you've got x squared minus y squared plus 20x minus 156 equals 0. And then looking at the imaginary part, you've got 2xy, and then you've got minus 20y, and that equals 0. So we can just solve them simultaneously. So looking at the imaginary part, because that's a simple one to solve, 2xy equals 20y, so y's cancel, 2x equals 20, we've got x is 10 straight away. We know x is now 10, so we can just do 10 squared minus y squared plus 20 times 10 minus 156 equals 0. 100 minus y squared plus 200 minus 156 equals 0. So that's 300 minus 100 is 200 minus 56 is 144. So you get minus y squared plus 144 equals 0. You can solve that directly or with double brackets, it's your choice. I'll just do it directly. Y squared is 144. That implies y equals the root of 144 but plus and minus. So y equals 12 or y equals minus 12. Z is x plus iy. So z1, first solution, x is 10, 10 plus 12i. And the second solution must be the complex conjugate, which it is 10 minus 12i. Two solutions for a quadratic, so we're done there.
Question 7, the complex number z equals 3 plus I is a root of z squared minus 6z plus a, where a equals 0, where a is a real number. Part A, nice and simple, state the second root of z squared minus 6z plus a equals 0. Well, that is just going to be z equals 3 minus I. In other words, the complex conjugate of our original z. Part B says, hence otherwise find the value of a. So we've got our complex divisors, so we've got z minus 3 plus I times z minus 3 minus I. So we can expand our brackets in the normal way. So that gives us z squared minus z times 3 minus I minus z times 3 plus I minus 3 plus I 3 minus I. It'll be a plus actually, because minus times a minus is a plus. So that implies we've got z squared minus 3z plus iz minus 3z again minus iz plus 9 minus 3i plus 3i is nothing minus I squared. So that implies that we've got z squared minus 6z. These cancel each other. Plus 9. And then I squared is minus 1, so plus 1. Because remember, I squared equals minus 1. So that implies we've got z squared minus 6z plus 10. And our original, remember, was z squared minus 6z add a. And therefore, a equals just the number 10. 6c, the expression z squared minus 6z add a is a factor of z cubed minus z squared minus 20z add b, where b is a real number. Find the value of b. So since it's a factor, we can just divide. And since it is a factor, the remainder will be 0. So we can just do that. So let's set up our long division. We've got z cubed minus z squared minus 20z plus b divided by z squared minus 6z plus 10, because a is 10, remember, we've just worked that out. So z squared goes into z cubed z times. Times and through by z, then we get z cubed minus 6z squared plus 10z. Taken away from each other, that gives us nothing, and it gives us 5z squared, and we get minus 30z plus our b on the end. So z squared, that's squared, sorry, 5z squared. Z squared goes into 5z squared 5 times. So that gives us 5z squared minus 30z plus 50. Take them away then. That's nothing. That's nothing. And that gives us b take away 50. But remember, z squared minus 6z plus 10 is a factor. So that implies the remainder must equal 0. So that implies b minus 50 equals 0, and therefore b equals 50. And we're done. Question 12, let z equal cos theta plus I sin theta. Use the Moivre's theorem to state an expression for z4. So part A, nice and simple. Z4 is simply cos 4 theta plus I sin 4 theta. 1 mark. No real problem there. Question B, state and simplify the binomial expansion of cos theta plus I sin theta to the power of 4. So we've got cos theta plus I sin theta to the power of 4. I'll need quite a bit of space for this one. So we've got 4 choose 0 of cos 4 theta. And then we'll have 4 choose 1 cos cubed theta. I sine theta. And then we'll have 4 choose 2 of cos squared theta. I sine theta squared, which we'll work out in a minute. 4 choose 3 of cos theta. I sine theta cubed. And lastly, 4 choose 4 of just I sine theta to the power of 4. Remember, I is, so tidying this up, so 4 choose 0 is 1, so we've got cos to the power of 4 theta. 4 choose 1, well, that's 4 factorial over 1 factorial, 3 factorial if you were taking your time, which is just 4. So you've got 4i. Cos cubed theta sine theta. Then you've got 4 choose 2, so that's 6. And then it's cos squared theta sine squared theta. But it will be minus because I squared is minus 1. Moving on to our next one, 4 choose 3. So that's 4 again. So we're going to have 4 cos theta sine cubed theta. And I cubed, well, I squared is minus 1. So minus 1, and then I've still got an I. So minus 4i. And the last one, 4 choose 4, is just 1, of course. I to the power of 4 is I squared is minus 1, so minus 1 times minus 1 is plus 1. So we're just going to have plus sine to the power of 4 theta. Part C says, hence show that cos 4 theta equals 8 cos to the power of 4 theta minus 8 cos squared theta plus 1. So part 1, we already know that cos theta plus I sine theta to the power of 4 from the Moivre's theorem is cos 4 theta plus I sine 4 theta plus 4i cos cubed theta sine theta minus 6 cos squared theta sine squared theta minus 4i cos theta sine cubed theta plus sine to the power of 4 theta. So we can see that this is made up of a real part and an imaginary part. So if we just equate the real parts, we'll end up with cos 4 theta. So equate the real parts. So that implies that we've got cos 4 theta equals cos to the power of 4 theta. Second term's imaginary. Minus 6 cos squared theta sine squared theta. Next term's imaginary, but then we've got plus sine to the power of 4 theta. So cos 4 theta equals cos to the power of 4 theta minus 6 cos squared theta. Sine squared theta is 1 minus cos squared theta. And since sine squared theta is 1 minus cos squared theta, then we'll have plus 1 minus cos squared theta squared, because sine to the power of 4 theta is sine squared times sine squared. So now we've got everything in terms of cos. Tidying that up further, we've got cos to the power of 4 theta minus 6 cos squared theta plus 6 cos to the power of 4 theta plus 1 minus 2 cos squared theta plus cos to the power of 4 theta. So cos 4 theta equals 168 cos to the power of 4 theta minus 8 cos squared theta plus 1 as required. Okay, part 2, sine theta cot 4 theta can be written in terms of cos theta only. So sine theta cot 4 theta, well, that's just sine theta times the cos of 4 theta over the sine of 4 theta. So that equals sine theta 8 cos to the power of 4 theta minus 8 cos squared theta plus 1 all over sine 4 theta. Okay, part B told us that cos 4 theta plus I sine 4 theta equals, I'm just going to paste this in. So if we want to know what sine 4 theta is, we can just equate the imaginary parts, because we've got an I here, to the imaginary parts of this hand side. So equating imaginary parts, sine 4 theta must equal 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. Subbing it in, well, that's what we've got. That's going to be sine theta 8 cos to the power of 4 theta minus 8 cos squared theta plus 1 all over 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. Taking sine theta out as a common factor on the top, we've still got, but taking it out on the bottom as well so we can get rid of the sines. So sine theta is a common factor. So it's 4 cos cubed theta minus cos theta sine squared theta sines cancel, of course, so on the top we get 8 cos 4 theta minus 8 cos squared theta plus 1 over 4 times cos cubed theta minus cos theta times 1 minus cos squared theta for sine squared theta. And that equals 8 cos 4 theta minus 8 cos squared theta plus 1 over 4 cos cubed theta minus cos theta plus cos cubed theta. That equals 8 cos to the power of 4 theta minus 8 cos squared theta plus 1 over cos cubed plus cos cubed, 2 cos cubed, 8 cos cubed theta minus 4 cos theta. SQL Advanced Higher Maths 2023, Paper 2, Question 6. Use the Euclidean Algorithm to find D, the greatest common divisor between 703 and 399. Okay, part A. So D between 703 and 399. So we've got 703. Well, that is going to be 1 times 399. And then to get your remainder, take away 399 and you get 304. And then we just start again. So 399, that's equal to 1 304s. And the remainder in this case is 95. Starting again with 304. Well, this time that is going to be 395, so if you're not sure, use a calculator. And the remainder from that is 19. So then finally, 95 is 5/19ths. So 0 remainder, and therefore D is equal to 19. And we're done for part A. Part B, find the integers A and B such that D is equal to 703A plus 399B. So for part B, D equals 703A plus 399B. So D was 19, so starting from this line, 19 equals 304 minus 395s. 19 equals 304 minus 3 times 95. And then we can just keep jumping up. That means that 19 equals 304 minus 3 times whatever 95 is. Well, 95 we'll get from the next line. 399 minus 304. 399 minus 1 times 304. And that equals, well, we've got 304 minus plus 3 304s. So that's 4 times 304 minus 3 times 399. And then moving on to our next line, well, 304 is 399 minus 95. So that means that 19 equals 4 times 399 minus 1 times 95. I suppose I could put 1 times, and that's minus 3 times 399. So we can simplify that to 4 lots of 399 minus 3 lots of 399 is 1 lot of 399 minus 4 lots of 95. So moving up again, 304 is 703 minus 399. So that means that 19 equals 4 times 703 minus 1 times 399. And we've got minus 3 times 399 still. So that 19 equals 4 times 703 minus 4 399s minus 3 399s is minus 7 times 399. So A is equal to 4 and B is equal to minus 7. And we're done there. Part C, hence find integers P and Q such as 76 equals 703P plus 399Q. So notice the connection between 76 and 19. 4 19s is 76. So that means that I can say that at the side, I suppose that 76 equals 4 times 19. So 76 is equal to 4 times the whole thing answer we just got, which is 4 times 703 minus 7 times 399. So that means that 76 is equal to 4 times 4, which is 16, times 703. 4 7s is 28, minus 28 times 399. In other words, P equals 16 and Q equals minus 28. And we're done there. SQA Advanced Higher Maths 2023 Paper 2 Question 9. Express 572 base 10 and base 9. So we've got 572 in base 10. So what does that mean? That means 5 times 10 squared plus 7 times 10, I suppose, plus 2. Now we need to express this in base 9, so we can just repeatedly divide by 9. Okay, so we've got 572 divided by 9. So 9 6s is 54. 54 for 5, 6, 7, 3 left over. 9 3s is 27. 27, 28, 29, 30, 1, 32, remainder 5. So we get immediately 572 divided by 9, right here, is equal to 63, remainder 5. So then we can just divide 63 by 9. Well, 63 by 9 is pretty simple. It's 7, remainder 0. And then taking our 7 divided by 9, well, we get no 9's going to 7, so 0. And we've got a remainder of 7. and therefore we can just read it backwards 705. So 57 to 2 in base 10 is equal to 705 in base 9, and we're done there. Consider the statement for all odd numbers n squared plus 4 is prime. Find a counterexample to show that the statement is false. Nice and simple, this one. We just need to find the number odd. So we just try it in our heads. 1 squared plus 4 is 5. 3 squared is 9 plus 4 is 13. 5 squared is 25 plus 4 is 29. 7 squared is 49 plus 4 is 53. 9 squared is 81 plus 4 is 85. Oh, look, that's in the 5 times table, so it's not prime, so let's just write that out. So for n equal to 9, 9 squared plus 4 equals 85, which is not prime, as you can find the number 5 times 7 equals 85. So we've proved it by counterexample. Okay, part B. Prove directly that the difference between the cubes of any two consecutive integers is not divisible by 3. So let's take an integer, any one we want. Let's call it n. Then the next consecutive integer is clearly n plus 1. N plus 1 cubed minus n cubed. Expanding n plus 1 cubed, we get n cubed plus 3n squared plus 3n plus 1 minus n cubed. We've used Pascal's triangle for that. That implies we've got n cubed minus n cubed is nothing. We've got 3n squared plus 3n plus 1. Should be able to see then there that we've got 3 bracket n squared plus n plus 1. So let's just call that m. That's 3 times m. So 3m is divisible by 3. And therefore, obviously, 3m plus 1 is not divisible by 3. As there is a remainder of 1. Always a remainder of 1. The difference between the cubes of two consecutive integers is never divisible by 3. Done. Basically, Advanced Higher Maths 2023, Paper 2, Question 12. Prove by induction that for all positive integers, n, the sum of y equals 1 to the n of 2 to the r minus 1 times r is 2 to the n minus 1 plus 1. So let's prove it for n equal to 1. Let's prove. And then we'll do for k, and then k plus 1 should follow. So for the left-hand side, we get r equals 1 to 1 of 2 to the 1 minus 1 times 1. Now that gives us 2 to the 1 minus 1, 0, so 2 to the 0 times 1, which is just 1. And the right-hand side should follow. We get 2 to the n equals 1, 1 minus 1 plus 1. That's 2 times 0 plus 1, which equals 1. So it's true for n equal to 1. And now we're going to assume it's true for n equal to k. So assume true for n equal to some number k. So we can write the sum, that means the sum of I equals 1 to k of 2 to the r minus 1 times k times r equals 2 to the k minus 1 plus 1. And now we want to prove it for n equal to k plus 1. So we're going to prove for n equal to k plus 1. So let's look at k plus 1 then. Looking at our left-hand side, that will give us the sum of r equals 1 to k plus 1 of 2 to the r minus 1 times r. And the game here is, I suppose, to pull this out to see if we can get some sort of composite sums that are add or take away, but we already know the answer to. So what does that equal? Oh, equal the sum of r equals 1 to k of 2 to the r minus 1 times r plus the k plus 1th term. Well, what is the k plus 1th term? It's going to be 2 to the k plus 1 minus 1 times k plus 1, because that's the k plus 1 when r is k plus 1. So then we'll just tidy that up. We already know the sum of I equals 1 to k of 2 to the r minus 1 times r, because we said it was true for n equal to k, so we can sub in this right-hand side. So that gives us 2 to the k minus 1 plus 1. Plus r. Now, we can tidy this up slightly. That's k plus 1 minus 1, which is 2k, just k, 2 to the k times k plus 1. So we've got 2 to the power k as a common factor. We can just leave the 1 on the end. So that means we've got 2 to the power k, and we've got k minus 1 plus k plus 1. And we've got our plus 1 hanging around the end. So we can tidy that big bracket up. We've got k plus k is 2k, minus 1 plus 1 is 0, plus 1. 2 to the k times 2k, well, basically that's 2 to the 1, so we can add the powers, so that gives you 2 to the k plus 1 times k plus an extra 1 on the end. So that's our left-hand side. Now I suppose it's worth looking at what our right-hand side would be. So if we look at our right-hand side of this, we have got 2 to the n minus 1 plus 1. Let's just write that down. 2 to the n minus 1 plus 1. So this doesn't look quite like that, but when n equals k plus 1, that implies we get 2 to the k plus 1, k plus 1 minus 1 plus 1, which is the same as 2 to the k plus 1. K plus 1 minus 1 is just time k plus 1. So we've got the same result from the left and the right, and therefore the sum of r equals 1 to k plus 1 of 2 to the r minus 1 times r equals 2 to the k plus 1 minus 1 plus 1. Just write a little statement to say it's true for n equal to k, and implied it was true for n equal to k plus 1. And since it was true for n equal to 1, then by induction, it will be true for all n a member of Z plus. And we're done there.
Higher Maths 2024 Paper 2 Question 5. State and simplify the general term of the binomial expansion of this, and then find the coefficient of 1 over x to the 18. So start of the exam paper tells you that n choose r, well it's the sum of, but we're just wanting the general term, a to the n minus r, b to the r. So r in this case is 16, okay? And what's our a and b? Well, a is just 2x squared, of course. B is minus 1 over x cubed, and
we can say that n is equal to 16. Now I might as well just change that to minus x to the minus 3 straight away for my substitution. So we've got 16 choose r, 2x squared, 16 minus r, minus x to the minus 3 r. And then we need to just collect the terms in terms of x's and numbers basically. So you've got 16 choose r, you've got 2 to the 16 minus r, x squared to the 16 minus r. So the minus x you can think of as being minus 1 to the r, and then this leaves you with x to the minus 3, so minus 3r. So that's 16 choose r, 2 to the 16 minus r, minus 1 to the r, x to the 2 16s is 32, minus 2r, and then x to the minus 3r, and finally we get 16 choose r, 2 to the 16 minus r, minus 1 to the r, x to the 32 minus 5r, and we're done there. So I find the coefficient of 1 over x to the 18. Over x to the 18 is x to the minus 18. That implies 32 minus 5r is minus 18. So minus 5r is minus 32 minus 42 minus 50. So r is 10. And now we know that. It is easy. We get 16 choose 10. 2 to the power of 16 minus 10 is 6. Minus 1 to the power of 10. And it's just a coefficient, so we don't need to write anything to do with x. It's just a coefficient. 16 choose 10 times 2 to the power of 6, and minus 1 to the power of 10 is 1. So that's just 512, 512, and we're done there. Use binomial theorem to expand 1 over x minus 3x to the 4. So we've got a plus b to the n equals the sum of r equals 0 to n of n choose r, a to the n minus r, and b to the r. So in this case, r is 4. So since it says use binomial theorem, I'm going to write the whole thing out to be on the safe side. 4 choose 0. I've got 1 over x to the 4. 4 choose 1. 1 over x cubed. And then I introduce the minus 3x. Then 4 choose 2. 1 over x squared. Then minus 3x squared. 4 choose 3. 1 over x minus 3x cubed. And finally 4 choose 4. 1 over x disappears to get minus 3x to the 4. So that's our first position. We can just use Pascal's triangle. So Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and so on. But it's this line I need. So it is 1 times 1 over x to the 4. So it's that line we want. So it's 1 times 1 over x to the 4 plus 4, 1 over x cubed, and then it's minus 3x, and then 6, 1 over x squared minus 3x squared, 4, 1 over x minus 3x cubed plus 1 over x. Well, that's gone actually, so no 1 over x minus 3x to the 4. So expanding that out, we've got 1 over x to the 4, and then we've got 4 3s is 12, and then you'll have x cubed on the bottom but an x on the top, so x squared on the bottom. And then you'll have 3 3s is 9 times 6 is 54. And the x's, well, you'll have x squared on the top and the bottom, so they just cancel out. And then you'll have 3 3s is 9 times 3 is 27. And then you've got 27 times 4. Well, 27 becomes 50. 4 becomes 108, and it's a minus 108. X cubed on the top divided by x is x squared. And then finally, 3 3s is 9 times 3 is 27 times 3 is 81. So plus 81x to the 4. And I'm pretty sure that we can just leave it like that. So we're done there.
SQA Advanced Higher Maths 2024, Paper 1, Question 3. A geometric sequence has positive terms. And SQA Advanced Higher Maths 2024, Paper 1, Question 3. A geometric sequence of positive terms has the third term 36 and the fifth term 16. Find the common ratio. So a geometric sequence goes AR squared, AR cubed, and so on. So AR squared is 36. And similarly, AR cubed, AR4 must be 16. Where R is the common ratio, so we just divide them together. AR4 over AR squared is 16 over 36. And 4 goes into both of them. 4 4s is 16 and 4 9s is 36. So dividing that through, R squared is 4 9ths, which means that R is equal to the square root of 4, which is 2, over the square root of 9, which is 3. 2/3, and we're done there. Part B says, calculate the value of the first term. Well, the first term is A. So, just using AR squared equals 36. A times 4 9ths, because that's R squared, equals 36. So, A equals 36 divided by 4 9ths. 36 times 9 quarters. Well, 4 9s is 36, so that's 9 times 9, which is 81. So the first term is 81. And then the last bit says, C, state why it has a sum to infinity. Well, this was B, by the way, and that was A. C, it has a sum to infinity because minus 1 is less than 2/3, which is less than 1, in other words. So that's all you need to say. Question D. I'll just put therefore the sum to infinity exists. Question D. Find the value of the sum to infinity. So the sum to infinity for this sort of sequence is A over 1 minus R. So A is equal to 81 over 1 minus 2/3. 81 divided by 1/3. That's 81 times 3 then. 3 1s is 3, 3 8s is 24, 2 4 3, and we're done there. X plus 5, 3x plus 2, and 5x minus 1, where x are a member of the natural numbers. Show that the first 3 terms form the start of an arithmetic sequence. Okay, let's start doing that. So let's say x plus 5 is u1. 3x plus 2 would be u2, our second term, and 5x minus 1 would be u3. Let's check the common difference between each of the terms. So let's do the first two, u2 took away u1. That is 3x plus 2 minus x plus 5. That equals 3x minus x is 2x, 2 take away 5 is minus 3. And then let's check the common difference between the next two terms, u3 minus u2. That gives us 5x minus 1, take away 3x plus 2. That is 2x minus 3. So since it's got the same common difference, that implies u1, u2, u3 form an arithmetic sequence with A being equal to x plus 5 and D, a common difference being 2x minus 3. Part B, find a simplified expression for the 15th term of this sequence. So un, remember, equals A times plus n minus 1 D. And we've already know that A equals x plus 5. d is 2x minus 3, and n is the 15th term, so 15. So we get u15 equals x plus 5 plus 15 minus 1 times 2x minus 3. So u15 equals x plus 5 plus 14 2x minus 3, which is x plus 5 plus 28x minus 3 tens are 30, 3 fours is 12, 42. So u15 must equal 29x minus 37. The sum of the first 20 terms of a sequence is 1, 130. Find the value of x. So remember, the sum is n over 2, 2a plus n minus 1d. Okay, so we want to find we know the sum of the first 20 terms of a sequence. So that's 20 over 2. 2 times a, but remember a is x plus 5. Plus n minus 1, well, just 19 times our common difference, which is 2x minus 3. Okay, so that implies we've got 10 on the outside, 2x plus 10 plus 38x minus 57. So that's 10 times 40x minus 47. That's 400x minus 470. And remember that equals 130. Should have divided by 10 first, but never mind. So we've got 40x minus 47 is 113. That gives us 40x equals a nice round number of 160, which implies that x must be 4.
SQA Advanced Higher Maths 2024, Paper 2, Question 7. Find and simplify the Maclaurin expansion up to including the x cubed term for e to the 2x, sine 3x, and then you have to do something together with that. So let's just do part 1 first. Now you might have memorised e to the x already, but if not, just start from the start. So we've got f of x is f of 0 plus f dash 0x plus f double dash 0x squared over 2 factorial, of course, plus triple x cubed over 3 factorial, and you could go on like this forever. So we've got e to the 2x, that's f of x. So f of 0 is equal to just 1. F dash x is 2e to the 2x, so f dash 0 is 2. F double dash then is 4e to the 2x, so f double dash is 4, and so on. You'll get 8 again, but we'll just see. So f triple dash 0 is 8. So we can say that f of x is equal to 1 plus 2x plus 4x squared over 2 plus 8x cubed over 3 factorial, which is 3 times 2 is 6, plus blah blah blah. We've only got the x cubed. 1 plus 2x plus 2x squared. Divide by 2 to get 4x cubed over 3. And they're done there. This is sine 3x. Again, you might have memorised sine x and just put 3x in, but if not, just start from the beginning. Doesn't take too long. Sine of 0 is 0. That's good. G dash x, 3 cos 3x. So g dash 0 is cos of 0 is 1, so that's just 3. G double dash is going to oscillate. We're going to go back to sine. That's going to be minus 9 sine 3x, which means g double dash 0 is still 0. And the triple dash is minus 27 cos 3x. So g triple dash 0 is minus 27. So now we can sub in, we can say that g of x equals g of 0, which is 0, plus, remember it's up here, g dash 0x, so that's 3x plus 0, that's x squared, and then the x cubed minus 27 x cubed over 3 factorial, which is 6. Simplifying that off, we get 3x, 27 and 6, 3 goes into both of them by 9, x cubed over 2. I'm happy with that. Part B says, hence find the Maclaurin expansion up for e to the 2 sine 3x up to the x cubed term. Okay, so e to the 2 sine 3x, and we've just done e to the 2x and we've done sine 3x. So that's appearing in there. So if I expand this out, e squared sine 3x we already know. 3x is this up here, 3x minus 9x cubed over 2. That's it as a Maclaurin. So then it's just e to the power 2 of that. Well, imagine that as like a variable x or y. We know e to the 2x from up here, so we can just use that. 1 plus 2x plus 2x squared plus 4x cubed over 3. So that gives me 1 plus 2x, but this is now my x, so 3x minus 9x cubed over 2 plus 2x squared, 3x minus 9x cubed over 2 squared, and 4x cubed over 3, 3x minus 9x cubed over 2 to the 3, and it's over 4 over 3, isn't it? 4 thirds. So then we just try and expand and simplify that. Now remember, you only need to go up to x cubed, so you can know a lot of them. So that gives me 1 plus 6x. 2's cancel, so minus 9x cubed. So I've done that line. Next line, 2. I'll have 3x times 3x is 9x squared. Timesing these together, 3 times 9 is 27 over 2 times 2 is 27. So minus 27 x to the 4, which you can just ignore, and then minus, I'll just put 9 over 2 x cubed squared, because you can just ignore that one anyway, and you can ignore that one. So that gives you that to expand, plus 4 thirds. And then you're cubing everything, so you get cubed, and then you get squared, squared, cubed again. So the 3x cubed is going to come in. But then what you'll have is, you will have a term here squared times a term here. And that's always going to be too big. And similarly, when you do that times that, that'll be too big. And then the final answer will be too big. So you can just ignore the rest. And if you don't realise that, just write it out. So that gives me 1 plus 6x minus 9x cubed. 2 9s is 18x squared. And 3x cubed, I'll just do this at the side, is 27x cubed. So 27 divided by 3 is 9. 9 4s is 36. So plus 36 x cubed. So then simplifying that a little bit with x cubed, you get 1 plus 6x plus 18x squared. 36 minus 9 is 27 plus 27x cubed. And there would be other terms, but we'll just not work them out. And we're done there. Advanced Higher Maths 2023, Paper 1, Question 7. Find an expression for the sum of 1 1 to n of r squared plus 3r in terms of r and express your answer in this form. So again, from the start of the exam paper, the sum of r equals 1 to n, well, we've got two there, we've got r squared plus 3 times the sum of r equals 1 to n of r. So you can actually just use that exam paper for this if you don't memorise this stuff. R squared is n plus 1 to n plus 1 over 6. And plus 3 times the sum of r equals 1 to n is just n plus 1 over 2. That's an n over 2. And then we can just tidy that up. So making it r to 6, we get n plus 1 to n plus 1. Times in this second fraction by 3, we get 9n n plus 1, and that's all over 6 then. Taking out n plus 1 as a common factor, we've got 2n plus 1, and then n plus 1, so plus 9, all over 6. That's n plus 1, 2n plus 10, all over 6. And it says leave it divided by 3 or a third. So I want to take a third out, n plus 1. So I've divided the bottom by 2, so I can divide the top by 2 to get n plus 5. And we're done there. Part B says, hence I always find the sum of I equals 11 to 20 of r squared plus 3r. So part B, the sum of r equals 11 to 20 of r squared plus 3r is equal to the sum of r equals 1 to 20 of r squared plus 3r minus the sum of r equals 1 to 10 of r squared plus 3r. And we've got a third n plus 1, n plus 5 for r equals 1 to n. So n is 20 in the first one, so we've got a third of 20. 20 plus 1 is 21, 20 plus 5 is 25, minus, and then our n equals 10, so we've got a third of 10 times 11 times 15. So we'll do a little bit of maths. 21 divided by 3 is 7, so we've got 7 times 20 times 25, minus 15 divided by 3 is 5, 5 times 10 times 11. 10 25 is 250, times 2 is 500, 7 times 500 is 3,500 for the first term, 5 times 10 is 50, times another 10 is 500, plus 1 is 550. 3,500 minus 550 is 2,950. And we're done there.
Paper 1, question 5. A function is defined as f of x equals x cubed minus x. Determine whether it's odd, even, or neither, and then show that it's got a point of inflection. So part A. If we want to show that it's odd, even, or neither, we're going to have to examine f of minus x. So subbing that in, that's minus x cubed minus x. So minus x cubed is minus x cubed plus x. So minus x cubed plus x, well, what happens if I put a minus here? I get minus x cubed minus plus x. So that's equal to minus x cubed minus x, which is minus f of x. So as f of minus x equals minus f of x, we can see the function is odd. And we're done there. Show that a graph of f of x has a point of inflection. So if we're going to get a point of inflection, we're going to examine the second derivative and see whether it's undefined or 0 at some point. So f of x is x cubed minus x. F dash x then, of course, is going to be 3x squared minus 1. F double dash is going to be 6x. So possible inflection when 6x equals 0, so x equals 0. And then we can just examine whether there is a change in concavity or not by just drawing a little table for ourselves. So we're going to go along, either side is 0. So as we approach, so in other words, 0 minus, 0 plus, we're looking at the second derivative here. So just before, when it's minus, so 6 times a minus number is a minus number, so that's negative. That's 0. And just after 0, like it's tiny little bit, it becomes positive. 6 times positive is positive. So you've kind of got this. So it is a change of concavity. So therefore, change in concavity therefore point of inflection exists. And that's that one done.
Squared Advanced Higher Maths 2025, Paper 1, Question 6. On a suitable domain, a curve is given by the equation y equals f of x, where f of x is that. Express that in this form. So we've got x squared on the top and x on the bottom, so I can divide because the power on the top is bigger or equal to the one on the bottom. So for part A, x squared plus x plus 5 over x minus 2. X goes into x squared x times. That gives me x squared when I times out minus 2x. Take away. X minus 2x is 3x. And then I've still got the plus 5 hanging about for the ride. Now I go in again. X into 3x is 3. That gives me 3x minus 6. Take away. That gives me 5 minus 6 is 11. So that means that f of x is equal to my quotient, x plus 3, plus my remainder, 11, which is over x minus 2. And we're done there. Part B, state the equations of the vertical and non-vertical asymptotes of the curve. It doesn't ask us to justify it or anything, it just says state. So for part B, vertical, well, that is when the denominator of the new thing, or the original thing, it'll make no difference, x minus 2 is equal to 0, can't divide by 0. So it's when x equals 0. Sorry, it's when x equals 2. And then non-vertical, not horizontal in this case, it's actually slanted. Because of division, you'll be left with this x plus 3. So that is actually it, y equals x plus 3. If that was just a number here, then it would just be y equals 3, which would give you vertical, but you've got the x plus 3 there, so it's non-vertical. No justification required, it's only worth 1 mark each, so I think we can just stop there.
That's Mr. Clelland from Clelland Maths. Today you did the Ultimate Advanced Higher Maths Prelim Revision video. Hopefully you found that useful, hopefully it was great. Just give it a like, give it a share, get the word out there that this is about now, and I'll see you soon.